So we've spent a little bit of time learning about how there's primitive variables, reference variables, there's immutable strings, and a tiny bit about what they do behind the scenes in memory. Now, this is all building up to this topic here, which is the idea that parameters are copied when a method accepts parameters. Now, what does this mean? Let's do a big test class here and sort of show you the general idea. Now, first thing we want to show you here is I've written this class called test class. Now, test class just has one role. I've written a method for each type of variable that we've taken a look at, and the method tries to change the variable. So you'll see here, this method called double me takes an integer, a primitive type in, doubles it. Inside of the method, I print out the new value of x, and then I'm also going to print out the value of x way afterwards, okay, in my runner class. You'll see here I have one called add z, so whatever string is brought in, it tries to add a z on. You'll see here I have a class called secret number, which is a very simple class. We'll just show it to you here. All it does really is holds an integer called value. Okay, that's really it. And I try to make that secret number, hey, access your value, and up it by 1. And then I have the last type here, which is an array. Now, an array is an object, so it should behave exactly like this, and we'll just confirm it does. Secret number is an object. Arrays are objects too. And those are really the four types we have to look at: primitives, strings, and objects. So let's see in my runner class here how I'm going to do this. So in my runner class, I make an instance of test class, and I'm just going to test each of these methods out to see what it ends up doing. So here I'm going, the number's 5. I tell the test class, run double me on my number. Now you know double me should double the number. So what should this print out? Well, let's take a look at what this ends up printing out. That's not the right file. And here's our printout of that line. And it says, in method, x is 10. So that came from here. While I was actually in the method double me, I took the 5 in, it became 10, and now it's printing out 10 in the method. But check out that output once we're back here on the system outline. The output of that was my number is now 5. Now this confuses a lot of people, and this is why we do this topic, because obviously you may say to yourself, hey, I thought I was doubling that number, but you're not doubling the number. So here's what's going on. When you send a parameter into a method, okay, so I send the value 5 in. It goes over to test class, dumps the 5 in, and here's what's really going on behind the scenes. You can imagine this line taking place, even though it's not written out. This is what that parameter integer x does. It really goes integer x equals whatever was just passed in. So we know whatever was just passed in was a 5. So what this method does is it creates a local variable called x, right, x, and it's set equal to 5. Visually, here's what you have. In your actual program, you had this thing called my number. I'm just going to write my num out. And it is set equal to 5. Once this method starts, it's not actually using the variable my num. Like we just saw here in the code, the whole deal with variables and parameters in Java is that parameters are always copies of the value. So integer x is created and set equal to the value passed in. So the method itself just made this variable x. X is set equal to that value 5. And this is what's used inside the method. Any changes you make, you're not making to my num, you're making to x. And so in the actual code, when you're making x double, you are not making my num double. You're making this brand new variable integer x that was just created. And so that's why in the method, yes, x is 10. The method ends, integer x is destroyed. We come back out of the method. We come here. My number is untouched because the method makes a copy of the value passed in. And so one thing I'm going to write later on in the summary down here is that methods in my test class, overall summary, primitive types, are they permanently changed if they're changed in a method? No. Okay? Because it's a copy of the parameter that's changed. Let's check out what happens with strings. Well, when you actually look at how I tested the strings out, strings were down here, the last one. I make a string called ABC. I tell it to run the method, add Z, and I give it S. S is now, and let's see what this did. And at the very bottom, S is now ABC. This is the exact same thing. It's making a copy, but remember from before, strings are also immutable. So when this method runs, string S, a brand new variable, is basically made in this method. So it sort of looks like that, string S, and it's set equal to the value. That value is ABC. This is now the string that's used for this method. So even though it adds a Z on, prints it out, once the method ends, that string S is destroyed. And so when you come back in to here, our original string S has been left untouched, just like a primitive. And so if we add this to our summary down below, are strings permanently changed? Nope, just the same as primitives. Now let's check out what happened with our arrays and objects. So let's test our secret number out. So I make this secret number, which will hold the value 99. Now this is an object this time, and we know that objects, the variables are called reference variables, right? Because they remember a memory address to an object. Now this is where it gets neat. I run this method change, and I give it the secret number called mystery. So it jumps in. It jumps up the change, and that variable I gave it called mystery is a memory address to a secret number. Now I do this, secret number SN. What this actually does is it makes a copy, but it's not making a copy of the secret object in memory. You have to remember what the thing I passed in was. Mystery is a memory address. Let's pretend this memory address is 123. So I pass in the value 123. Behind the scenes, this is what's written. Secret number SN equals 123, right? The parameter makes a copy of the value, and the value was a memory address. Now this is why this one ends up behaving differently than the primitives. When I say, hey, SN, well, SN is memory address 123. It goes to memory address 123, and what's there? A secret number, right? The secret number we passed in, and it makes the value go up. So when I print out in method, the value is going to go up, but you'll also see from the output, since we're now dealing with a memory address, whatever was at that memory address has also gone up. So the way to look at this visually is something like this. Whoops. Here we go. So I had my original secret number called mystery. And I'll just write mystery like this, mystery, and it held memory address 123. And memory 123 pointed to this object that held the number 99. Now when I go into the method, and this method says make a copy and call it SN. Well, let's do that. So I make this new reference variable called SN, and the copy is the copy of this, the memory address 123. So it also equals 123. Now because it's the same memory address, it technically points to the same object in memory. So now when I run a line of code like this, hey SN, up your value, it's going to go, hey SN, well that's memory address 123. That's here, up your value. So it changes the 99 to 100. Now notice, mystery is still also pointing to 123 because that is the value of mystery as well. So in all respects, mystery has also just gone up to 100. And so what's the overall effect here? You saw it in the output. It is permanently changed, whatever change you did in the method. And so if we had to summarize this one in our notes, whoops, down at the bottom here, are objects permanently changed? Yes, because you're dealing with reference types. Memory addresses are what the variables are storing. Now, are arrays permanently changed? Well, arrays are objects. We can just look at the output for this one. You'll see here my change array. Whatever I've been given, I take slot 0 and change it to 999. Is the change permanent? Well, we'll see here. My array started out just being 1, 2, 3. I call change array, and then I print out the array. Is the 1000 still there? And we'll just check the output here, and we'll see that the output of the array in the method, it's 99923, and after the method is called, the array is now 999923. And so the change is also permanent, like expected, because arrays behave exactly the same as objects. Nums is a reference, so it's a memory address that points to that array. And so if I add this down to our notes in test class, are arrays permanently changed? Yes. Now for the AP exam, is it okay just to memorize these 4 facts? I suppose, but it is nice to know a little bit why. It's because methods are always making a copy of the variable and using an entirely new variable with the exact same variable value. If the variable is a memory address, then it's going to affect whatever's at that memory address permanently. If it's not a memory address, it doesn't affect it permanently. That's pretty well it. Have fun with that one. A little bit of memorization. You might have to watch that again. The good news is that is something you have to know, since you will be using methods in a lot of your programs. You have to know whether your methods permanently affect things or not if you make changes to them. And it's nice to know that sometimes you can run a method and you don't even have to worry. The method in no way can make changes to your variables. So it is important knowledge too. Thanks for watching.